Water is important because the same water that you see like in the sink or out in the bay, that water is the same water that's been on the earth since the beginning. So it might have been the water that rained on a dinosaur, might have flowed down the Nile, or it might have flowed through the reef nets of our ancestors. But all of the water on earth is the same water. It's just being recycled over and over again, either as rain or snow, or in the ocean or in the rivers.
Surface water. Lummi Nation depend on the salmon, and the salmon depend on the water in the Nooksack watershed to be cold, clean, and clear. Cold meaning that the water is not too high in temperature, because the higher the temperature, the lower the dissolved oxygen. So the lower the amount of oxygen that the salmon have available to breathe in. Clean, because any kind of toxins are very dangerous to salmon and they cannot survive with too much toxins within the water. And clear, because water that has too much turbidity, too much sediment in it, is unhealthy for salmon. In order to monitor the water within the Nooksack watershed, the Water Resources Group within the Lummi Natural Resources do regular surface water runs where they are measuring different parameters that the water needs to be within. And when it's not within these parameters, they can troubleshoot to determine what needs to happen, where there's a source of problem coming from, and how they can proceed forward. Today we're going to follow Jeff Solomon and Shamania James on their surface water run, and we're going to see exactly what they do to make sure that the Nooksack watershed has cold, clean, and clear water.
Hello, I'm Jeff Solomon. I am a Lummi tribal member. I work for Lummi Nation Natural Resources Department in the Water Resources Division. I am what's called a Natural Resources Technician, which means I do a variety of stuff for the department, but my primary duties are monitoring surface water, groundwater, and I also do a good number of wetlands work.
Hi, my name is Shamania James. I'm a water resources technician for Lummi Natural Resources. Working with water is important because we want to make sure that that water is clean, clear, connected, complex, and safe for us to use.
The Water Resources Department does these marine surface water runs in one of two ways. One, like we've seen here, Shamani and Jeff do the surface water run along Marine Drive, and they hit several spots along the way. And they take samples from land of the water that's either flowing into the ocean or directly from the ocean. Another way that it's done is actually by boat. As you'll see here, some of the other Water Resources members are taking the boat out into the middle of the bay, and they have quite a few spots they take samples from as well. They do have a few other parameters that they might sample, for example, like turbidity, meaning how clear the water is. So this is just another way that they can get more information on the water out in the bay.
We are at the Portage Crossing, right at the very end of the peninsula. We are sampling water for bacteria, and the reason we do that is because if the bacteria levels are too high, and this particular area is an active clam bed used for subsistence harvest, commercial harvest. If the bacteria levels are too high, they can create unsafe toxin levels in the shellfish for consumption.
What's that in your hand?
This is my cool little iPad. This is how we take data in the field. And what we're measuring, aside from bacteria, are other parameters such as water temperature, air temperature, salinity, pH, dissolved oxygen. North? Okay, ready?
What's this thing?
This is a YSI, and it's used to monitor the water. We look at temperature, conductivity, salinity, DO percent and DO milligrams. DO just means dissolved oxygen, and pH.
So let's think about cold, clean, and clear. Cold, you can measure easily by looking at the temperature of the water. So here we can see that it's 4 degrees Celsius. We measure in Celsius. Salmon need colder temperatures because it actually means that there's more oxygen in the water. So the higher the temperature gets, the less dissolved oxygen is in the water. And that means less oxygen for the salmon to breathe. Clean. Now, if we think of clean, we think of pollution, different kind of pollutants. Think of next to the big farming places, there's runoff, big companies that have runoff, that have pollution going into the water. Everything runs into the water. So you have to know that everything that's on land, all the chemicals, all the pollution, once it rains, those can run off into our water systems. When it gets into the water, it's going to create bacteria. And these bacteria are also going to create big algae blooms. It's like a party for the algae. Now, during the daytime, algae perform photosynthesis, which is actually a positive thing. Algae is taking up carbon dioxide from the air and creating oxygen that it pushes out into the environment. However, at nighttime, algae does the opposite process. It actually performs respiration. And what happens then is that it consumes all the oxygen in its environment and releases carbon dioxide. So if there's a ton of algae in a waterway and at nighttime it consumes a ton of oxygen, it can leave very low levels of oxygen available for salmon. This means that sometimes you'll come across waterways that have algae blooms and you'll see dead fish. So it's important to keep the water clean with no pollutants so that there's still enough oxygen for the salmon. Pollutants can change the pH, they can change the conductivity and the salinity. All of these factors will affect the oxygen and will affect the temperature, which are two very important factors that salmon need to stay alive. Finally, if we think of clear, turbidity. Turbidity is like when you see the river and it's completely brown and there's so much dirt and dust that's picked up. That turbidity is actually not healthy for salmon at all. For one, it changes the temperature of the water. When the sun beams down, it heats up all those little particles floating in the water, and that makes the water as a whole a lot warmer, which, as I mentioned before, changes the amount of dissolved oxygen in the water. So there'll be a lot less dissolved oxygen.
Temperature is 4.18.
Temperature 4.18. 4.08.
And pH is 5.82. And it's about half a foot deep. And that's Now we're going to put the bacteria on ice.
What kind of bacteria are you looking for, or you're testing for?
3 different kinds: E. coli, Enterococcus, and fecal coliform.
What's fecal coliform?
Poop.
What's important with getting those numbers? If they're bad, like too high or something, what can you guys do as a water resources department?
If they're too high, it'll usually trigger an alert for us, wondering if there's a source that is contaminating the water, such as maybe poorly managed farmland. We've had that in the past. Sewage leaks, oil spills, anything that could pose as a threat to the water quality, which is used by wildlife for habitat, or even worse for our drinking water sources. Hey guys, so welcome to our freshwater sampling sites. You saw us sample at our marine sites at the end of the peninsula. Here at the Kauaina Slough, the sampling method is not much different, except it's a freshwater stream, and that's what we do for surface water, is monitor water that flows onto and through the reservation. Any questions? Amy's got the answers.